Okay, on to identifying the functional groups for the following molecules. So we have CH3, CH2, OH. So that OH is our functional group, and we call that an alcohol. CH3, CHO. So what does that look like? We have our CH3. We have a carbon. This has 2 oxygen, and it has 1 oxygen and 1 hydrogen. So we'll have to go OH. That gives everything the right number of bonds, 2 for the oxygen and 4 for the carbon. And what we call that a ketone. No, that's not what we call that. We call that an aldehyde, because it's on the end. When it's in the middle, like this one is, we call that a ketone. And then this OMe, what do we call that? That's called an ether group. When it goes oxygen, and then you have whatever on either side of it. That should be an oxygen. An oxygen with something on either side of it. Which of the following is not an isomer of the others? So remember, an isomer is a something that has the same number of each type of atom, but it has a different rearrangement. So let's go ahead and count all the carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So D is the only one that has a different number of carbons, so that's not our isomer. All of these, we didn't count the hydrogens, but they all have the same number of hydrogens, and we know that because we have only single bonds and no rings or double bonds or triple bonds or oxygens. So we know those all have the same number of hydrogens, even though we didn't count them. Okay, now on to some review. Draw a diagram showing 2 molecules of CH3OH hydrogen bonding with each other. So we'll want to draw our CH3OH first. Here's our 4 on hydrogen. Make sure you have 2 lone pairs on the oxygen. So there's our 2 molecules, CH3OH. So there's one of our hydrogen bonds, and we could also make a hydrogen bond there if we wanted to. So those are our 2 hydrogen bonds. Remember, hydrogen bonds cannot be formed with the hydrogens on a carbon, because those don't have any polarity. Only, I think it's HO, HF, and HN. Those are the only ones that can form hydrogen bonds. And remember, it's between the hydrogens and oxygens of different molecules. Okay, weak acid has an initial concentration of 0.050 molar and a Ka value of 1.8 times 10 to the negative 5th. What is the pH of the solution at equilibrium? So let's go ahead and let's do an ice table. So the first thing we have to do is write out the equation. So Ha plus H2O goes to A minus plus H3O plus. We have our I, C, and E. Remember, our water, we'll ignore it for all of those. HA, we know we start with 0.050, and we know we start with 0, A minus, that's just kind of assumed. Our change, so we'll take away negative x from this side, and since these all have coefficients of 1, that means we're adding x to the other side. Then at equilibrium, we'll just go ahead and add these columns up, and then we will put them into our equilibrium expression. So remember, you multiply the concentration of the product, so x times x, which is x squared. Put it over the reactants multiplied. We only have HA, so we'll just put 0.050 minus x. And we know that's equal to our Ka value of 1.8 e to the negative 5th. Okay, so remember our 0.050 minus x, that's just like adding pennies to the x. So it's not going to change it a whole lot. Remember, we keep it in the top, though, because we're multiplying it. So if you, multiply something by 100, that's way different than taking away a few pennies. So that's why we can ignore it in the bottom, but not the top. So then we'll solve for x. So x squared is equal to 0.050 times 1.8 e to the negative fifth. Take the square root of both sides. X is equal to 9.5 times 10 to the negative fifth molar. And remember, we have two sig figs for this concentration, 1, 2, so we have two here, but we're not interested in the concentration of H3O plus, which is equal to X, right? We're interested in the pH, and we know that concentration of H3O plus is equal to 10 to the negative pH, so we can take the negative log of both sides to get the pH. And so negative log of 9.5 times 10 to the negative fifth, negative log of 10 to 9.5 times 10 to the negative fifth is 3.02. Remember, only the sig figs for pH are the ones after the decimal, and that's only true for pH. So that has two sig figs. That 3 that's before the decimal doesn't count as a sig fig, so two sig figs there. Identify the acid, base, conjugate acid, and conjugate base for each of the following. NH4 plus H2O goes to NH3 plus H3O plus. So remember, an acid is a hydrogen donor, and our base is the H plus acceptor. So in this case, the NH3 plus is donating the hydrogen, and the H2O is accepting the hydrogen, and that makes our NH3 plus our conjugate base. You can also think of it as the NH3 is able to accept a proton and turn into NH4, and then our H3O plus is our conjugate acid. Okay, and here we have CO32 minus plus H2O goes to HCO3 minus plus OH minus. So in this case, our CO32 minus is accepting the hydrogen, making it a base. And since H2O is donating the water, that makes it an acid. HCO3 minus is the conjugate, and it's an acid because it can donate that H plus. It's also opposite what the base is, and then OH minus is the conjugate base. And water, so in this part A, it's acting as a base, and in part B, it's acting as an acid, and we call that, when it can act as an acid or a base, that's called being amphoteric. So that's just a good word to know. You may see that sometimes. Hey, thanks for watching, guys. Hope this helps.